I think it's probably even helping it because then you're switching the metabolism. What we've shown is that the P2HNF4 loves to turn on ketone bodies, loves to make ketone bodies. The P1HNF4 is much better at turning on gluconeogenesis genes. And so at the very beginning of this conversation, we were talking about the balance between lipids and carbohydrates.
Right.
And a lot of that occurs just through these two different forms of HNF4.
I see. So the relative abundance of version one and version two of this transcription factor, how much of version one you have compared to how much of version two, seems to be tied with the degree to which the cells are doing more carbohydrate-based metabolism versus fat-based metabolism.
Exactly, yeah. And so we had been studying these mice, and so we did transcriptomics, something called RNA-seq, where we take out the liver of the mouse and we look at all the genes that are expressed. So it's about 20-some thousand genes. And what we saw in these mice that expressed only the P2HNF4, there was a bunch of these cytochrome P450 enzymes that were, some were upregulated, some were downregulated. And we didn't really know about these cytochrome P450 enzymes. We hadn't paid attention to them before. And we looked into them and said, well, what substrates do these cytochrome P450 enzymes act on? So cytochrome P450 or CYP genes are known to metabolize xenobiotics. They metabolize the drugs you take. They also metabolize fatty acids and steroids and things like that. So we noticed that several of the cytochrome P450 enzymes that were downregulated in the P2HNF4 mice were actually metabolized, are known to metabolize linoleic acid, doing the first step towards oxylipins. So we put these mice, we call them alpha 7s, but we'll stick to the P2 nomenclature, the P2HNF4 mice. We put them on the soybean oil diet and they did not get fat. In contrast, we were blown away at how robust that result was, because usually in biology, it's like, okay, you can see something, right? If we put them also on the coconut oil diet, and they were the same as the wild type mice. So that the mice could take up fat. They didn't have a defect in just absorbing fat.
I see. So if you gave mice soybean oil with linoleic acid, they would get fat, and those mice can convert the linoleic acid into oxylipins. If you give them coconut oil instead, you don't see that because there's really no linoleic acid there for them to convert into oxylipins. And then if you take mice that are given the soybean oil, but they biologically can't really convert the linoleic acid into the oxylipins as much, they also don't get obese.
Exactly.
So it seems to be converting the linoleic acid from the soybean oil into these oxylipins that's driving the obesogenic effect.
Exactly. So with this, we could then say, yeah, it's not the LA linoleic acid per se. It's what the linoleic acid becomes. And it might sound kind of wonky, but this is actually really important to understand the mechanisms.
Right. Right.
And so we measured all the oxylipins and we confirmed that the oxylipins were way, way down. And the linoleic acid was high. So, yeah.
And do animals and or people naturally vary in their metabolism, in the versions of different enzymes they have, et cetera, in ways that would affect the sort of natural or background rate that one would convert linoleic acid into oxylipins or other things?
Yeah, no, that's a great question. So yeah, I teach cancer biology to undergrads here at UC Riverside. I've been doing that for about 30 years. And of course, we teach about toxicology because most chemical carcinogens are metabolized by the cytochrome P450 enzymes, right? So the cytochrome P450 enzymes, these genes are some of the most highly regulated genes and have differences, just genetic differences between people. Classically, they're regulated by diet, by age, by other drugs that you take, et cetera, right? And so if you were to ever, and so this really hit home when I was going over to Paris to do a sabbatical in 2003. I happened to be on a metoprolol for a heart condition, right?